In the previous lecture, we learned how to calculate a stock's simple rate of return. However, you should be aware that there is an alternative way to calculate returns. Instead of simple rates of return, we could use logarithmic rates of return, also called log returns. The difference between the two approaches is quite subtle. As we discussed in our previous financial lecture, given that we will explore the behavior of a single stock from the 1st of January 1995 until today, perhaps it will be better to use log returns. Again, NumPy will be the library that will provide us with the necessary tools for this computation. The benefit is that this package offers the possibility of vectorized computation. This term refers to the ability to organize several kinds of data processing tasks as array expressions, vectors, matrices, or multidimensional arrays. The alternative is writing loops, but that could be a tedious job and will require more computation time. In other words, NumPy is Python's extension that allows us to replace loops with one-dimensional or multidimensional arrays. This operation is called vectorization, and the relevant type of programming that supports it is array programming. Okay, so, as we agreed, to calculate log returns, we will have to take the logarithm of the price in time t divided by the price in t minus 1. Okay, so the first log return will be equal to the logarithm of the price on the 4th of January 1995 divided by the price on the 3rd of January 1995. We will need a new column, which will be called log return. The expression we will assign to it will be the following. Call the log function from the NumPy package. And in the parentheses, type the formula for calculating the logarithmic rate of return. That would mean taking the adjusted close of a given observation for a certain trading day and dividing it by the adjusted close of the day before. Again, we must specify the adjusted close data in brackets. And, just as we did before, we will use the shift function to lag the stock price observations in the denominator. The argument of the shift function is 1, as we need to lag the time series by a single observation. Great! We obtain a series again, and most of the values are less than 1%. When we plot the newly obtained data on a graph, we see the log rate of return ostensibly resembles the simple rate of return. However, when we calculate the average daily and annual log returns, we obtain a percentage that is significantly smaller than the one we obtained for simple returns. In general, it is preferable to use simple returns when we calculate the returns of multiple securities in the same period. On the other hand, log returns are a better choice when we have only one security and calculate its return over multiple time periods. Okay, great. Our first task is complete. Thanks for watching.